Hi guys, hope you're fine and doing well. So today we will be discussing this problem from the Codeforces Global Round 20, which is log chopping. So before starting the problem, if you're new to this channel, you can consider subscribing it and pressing the bell icon so that you don't miss any of the upcoming updates. So let's get started with this problem. So the question tries to say that we are given n logs of wood and the ith log has the length of a of I meters. And there are two players, player 1 and player 2 basically. So they can choose any of these logs and they can cut them into two pieces, and these two pieces should be integers. Like if it is 3, then they can divide it into 2 and 1, but they cannot divide like 1.5 and 1.5. So in the first, player 1 starts the game. So player 1 picks a log of wood and it cuts into 2, and then player 2 picks a log of wood and then he cuts it into two pieces. Similarly, the process will go on, and the person who is not able to choose a wood or divide the wood that he has picked up, that person will lose the game and the other will win. So we are given just these n logs of wood and we have to just output that which player will win the game. So now let's have a look at this test case. So since we know that player 1 will every time start the game. So firstly, player 1 will choose a log of wood. Let it be 4. So because both the players are playing optimally, so both of them will try to choose the largest size of wood. So firstly, player 1 will choose 4. So he will divide it into two pieces, which are 2 and 2. And next turn is of player 2. So he will choose this 2 and divide it into 1 and 1. So next time it is of player 1, so we will also choose 2 and again divide it into 1 and 1. Next is of player 2, so we'll choose this 1 and 1. So next turn, player 1, we'll choose this 2 and now 1 and 1. And now this is the important case where player two's turn comes and there is no other largest log of wood available to him except 1. So this one cannot be divided into any two pieces, and that too, those are integers. And in case it tries to divide it into 0 plus 1, so this is something useless. So it will always remain constant. So hence, this player 2 loses. And let's see a case like where, in case we are given 2, 2, and 1. So if we are given these logs of wood, and then player 1 will choose this 2 and divide it into 1 and 1, and then player 2 will choose this 2 and divide it into 1 and 1. Now player 1 turn comes. So he's not able to choose any other wood except this one. So in this case, when we were given this test case, so player 2 lost because the maximum length of wood that he was able to choose was 1. And in this case also, player 1 loses because the reason is same. The maximum length of wood that he can choose is 1. So this is how we come to know that the last player who chooses the length of 1 will always lose. So now let's have a look how can we approach to this problem. So firstly, one thing that we notice is we every time require the maximum length of wood. So max length of wood is required by each player. So the most optimal data structure that can provide us with the maximum length of wood every time, and when we add the other set of two divided woods is also. So this data structure is basically a max heap. And here we will be using max heap. So the reason is simple because every time this max heap provides us with the maximum element. So all the operations can be done in just log of n. Hence, we will simply just output not output, we will just pop out the element of this max heap, and then we will divide this element. Let this element be v, and then we will divide this v into two parts, which is v divide by 2 and then v divide by 2 plus v percent 2. So like in case of 3, it will be 1, sorry, 2 comma 1 comma 2. So that is the reason we just did v percent 2. So these operations will continue to be performed endless times, and where will be the base case is when this v element, which is the maximum element present in the whole heap, comes out to 1. And once it comes out to 1, we come to know that this particular player will lose this game. So how we will keep the track of players? We'll simply just keep a count variable and keep it incrementing. So we'll start count from 0, and when it enters here, it will become 1. So when count percent 2, basically c percent 2 is equal to 1, then that means it is player 1, and in case it is 0, so it is player 2. So that is how we will keep the track of players. So let's have a look at the code. So firstly, I took the input for n, which is the number of logs of wood available to us, and then their lengths. And here I have taken the input for count variable just to keep the track of like which player is currently choosing the log. And then I have maintained a priority queue, and here I have done collections dot reverse order. The reason is simple, because I want a max heap. In case I wanted a min heap, so this part will be just removed from here. And then I'll add all the elements of the array in this heap, and till the size is not equal to 0, I'll just run this loop. And obviously at any time this size cannot be 0. So firstly, we'll simply increment the count just to keep the track it is a player 1, and then we'll output the maximum length of the log out of the heap. And in case this value is 1, and what we will do is we'll simply have two options, that in case it is player 1, then we will break, and in case it is player 2, then also we will break, just keeping the count is equal to 0 or 1. And in case the count is 0, then the player 1 wins, and in case the count is like 1, then player 2 wins. This is just a flag pointer that we have kept for our simplicity. And the other thing that we'll do is, once we have outputted the maximum length of the wood, we'll divide it into two pieces and again add it into the same priority queue, and we'll simply output our answer. So I hope you understood the solution to this video, and if you appreciate my work, you can consider subscribing to my channel and giving thumbs up to this video. So let's meet in the next video. Till then, bye bye.